everyone, thank you so much for coming to this video. So today we're going to be going over some diagrams for stats. So the learning objective for today is to be able to interpret tables and diagrams for single variable data, and also to be able to understand that the area in a histogram represents frequency. So like always, there's going to be timestamps in the description of the video, so feel free to skip to any parts you want to, but let's get started. So I've laid out here the main graphs that you'll need to know for representing different types of data. So the first type is bar charts, dot plots, and vertical line charts. And these show how your data is distributed. So like how much, so for example, we have this dot plot here showing the frequency and your favorite drink. So each dot represents like one frequency. So if you could read off of here for A, for example, that 4 people like the drink A. And similarly, you have your bar chart here. And for A, the bar chart goes to 4, so it shows that 4 people also like drink A. So if you have bar charts, dot plots, and vertical lines, they just show like the frequency for each like X value you have. So for this example, it shows the frequency of people who like each favorite drink. The next one you have is stem and leaf diagram here. And again, they just show your different values for your data. So for example, if you wanted to show the ages of readers of newspapers, then you have the stem and leaf diagram, and you read it if you have 2 and then a -2, that's just equal to 22. So it just shows your stem and leaf diagram will show your different ages and like how many like what ages it ranges to, like your mode. You get your mode up here, like what's the most common age you have, what's the highest age, what's the lowest age, so you can get a variety of information from the stem and leaf diagram. But just remember to read it is you have to, it normally say how to read it on the side. So for this example, you have 2-2, and that's just equal to 22. So that's what a stem and leaf diagram is. Another type of diagram you could have is your histogram, and this shows your frequency density, and your frequency density is equal to your frequency over class width. So unlike your bar chart or dot plot, which show your frequency, this doesn't directly plot frequency, instead it plots frequency diagram. So that means that your area of your graph, of your bar, that represents your frequency, rather than like your point, your y-axis representing your frequency is the area of your bar, of your chart, of each of your bar that represents your frequency. So for example, if we were to work out the area of this first bar here, all you would do is you would just do your class width, which is 10, multiplied by your frequency density, which is 0.3. So you get this area is equal to 3. And if you would do your next one, we'd have your class, the area of this chart is just this X value, so your width, which is 10, multiplied by your frequency density, which is 0.8. So you just get 8 as your frequency for this chart, and so on and so on. So you just remember, for a histogram, your area is what represents your frequency, which is just your frequency density over your class width. So that's what a histogram shows. The next one you have are box plots, and they're really useful for showing like different like key like central tendencies and variations. So they show your median quartile really easily, your lower and upper quartile, and your lowest and highest value for your data. So yeah, if you were asked to show like if you were to compare like 2 data sets, for example, you could use box plots to compare your different medians or your different lower quartiles, and I've labeled the each of them here. So you normally have like a line with 2 little dashes on your end, and they represent your lowest and highest value, and then you have a big box in the middle. The lowest side of that represents your lower quartile, your upper length represents your upper quartile, and the side that you have in the middle, the line you have in the middle, that represents your median. So box plots are really useful when you're comparing different like medians, lower quartiles, and other like upper quartiles for different data sets. And you can easily get a box plot from your cumulative frequency diagram graphs. So these, instead of represent like plotting for each height, the frequency for that, it shows like how your frequency adds up for each height. So like here you'd read for up to height 150 you have no frequency, but then as you move on to 160 you add like around 12 and then so on so on. So at 150 you'd have the total number of students you have high up to 190 will be 90 people. And you can easily read off the median from here. So that's this middle line here. So your median is 170. And you can also easily read your lower quartile and upper quartile from here. So your upper quartile would be your highest red line, your lower quartile will be your lowest red line, and you can easily put that into your box plot. Our next video will tell you how to actually work out your median, lower quartile, upper quartile from your cumulative frequency diagrams and also from your other types of graphs. But for now, for this video, you just need to know what the different types of ways we can display data and the different types of information you can get from your different graphs. So bar charts, dot plots, vertical line charts. From them, you just get your frequency for each data you're trying to work out. For your stem and leaf diagram, it just shows your different values that you have, and it can be really useful for getting your mode. You can also work out your median from there. This is just through like cancellation. So you start from your lowest and ends, you go that, and then you'd go from your next one, next highest, and then you'd keep cancelling, so it'll be somewhere in the middle here. That's your median. Similar process, you can work out your lower and upper quartile. So you just get the number of values you have. So we have 1, 2, 3, 4, 5, 6. You divide it by 4, so you get 1.5. So your lower quartile would be your 1.5th value. So it'll just be 2.25. That's your age. Median, you do 6 divided by 2, so you'd get your third value. So it'll just be like 34. Your upper quartile, you do 1.5. So do 6 divided by 4 times 3, 1.5 times 3, and you just get that value. So you get your 4.5th value. So you get around 30, between 34 and 42. For histogram, you can easily find your frequency for that just using the area of your chart. Box plots really good for showing your median, lower quartile, upper quartile, and so are cumulative frequency graphs. They're really good for showing median, lower quartile, and upper quartile. So that's everything you need to really know about displaying data and the different ways to display data. Let's try a question quickly to see if you can use this information we've just gone through. So we have an exam style question here. Feel free to pause the video and try it out for yourself. So we have the variable x was measured to the nearest whole number. 40 observations are given in the table below. A histogram was drawn and the bar representing the 10 to 15 class has a width of 2 centimeters and a height of 5 centimeters. So for the 16 to 18 class, we want to find, first we want to find the width. So to do that, we just use the information we've given. So for the 10 to 15 class, it has a width of 2. So that means from 10 to 15, which is like 6 like numbers, that represents a width of 2 centimeters. And then for 16 to 18, we have 16, 17, 18. So for 3, how much is that going to represent? So if you do, so your 16 to 18th class, that's just a half of your 10 to 15 class. So then your width also has to be half of it. So then your width would just be 1 centimeters. And that's your answer to part A. And now for part B, we want to find the height of our 16 to 18 class. So we can do this kind of using areas and frequency density. So if you remember, for a histogram, your area represents your width times your area, which is your width times height, that represents your frequency. So you could say that for 16 to 18, your sorry, not your 10 to 15, your area, which is 2 times 5, which is 10 centimeters squared, that represents a frequency of 15. So now we somehow want to, so now we can, if we know that 10 centimeters squared is represented by 15, we can work out what a frequency of 1 could be represented by, like what area. So we could do 10 over 15, which is just, we divide them both by 5 to get 2 over 3. So that represents an area, a frequency of 1. So therefore, to get a frequency of 9, we could do 2 times 3 times 9. So that will cancel out. So we want 6 centimeters squared to represent a frequency of 9. So now we know our width is just 1. So to do our height, we just want 6 divided by 1, which is just 6 centimeters. And that's our height. So that's the answer to this question. So this is just using the fact that when you have a histogram, you have your width times your height is representing your frequency. So the area of your bar is representing your frequency. And you want to try and your width of your bar, that represents like your class interval. So for 10 to 15, that's represented by a width of 2. So you want to try and find out what an interval of 16 to 18, what that width of the bar would be. And then to find our height, we were using the fact that your width times height is equal to frequency. So we worked out what area a frequency of 1 would be represented by, and then use that to work out what a frequency of 9 would be represented by, and using the fact that width times height represents frequency, and we found using that our height was 6 centimeters. So now let's try another question. So we have another exam style question here. Again, feel free to pause the video and try it out for yourself first. So we have at a tourist information office, the number of people seeking information each hour over the course of a 12-hour day are shown below. First, we want to construct a sorted stem and leaf diagram to represent the data. So to do this, we just want to remember that in a stem and leaf diagram, if we have something like 2/5, that was equal to 25. So we just want to construct something like this to show all our numbers here. So we know we have in units, in tens of units, we start with 0, and the first value we have 6, and we have tens, we have 15 and 18, and we have 20s. So we have a 2 here, and we also have 30s. And now we just want to fill this in order. So for the first number in tens, we have 15. So we could do 1/5, and we also have 18, so we have 1/8. Then if we move on to the 20s, the first one we have is 2/1, 21. Then we have 2/5, so we have 25. And then we have 2/8, so we have 28. And then we have 2/31, so we could do 2 1s. Then we have 33. And then we also have 38 and 39, and just count to see we have 12. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're missing 1. So that was 35. So we forgot 35. So let's just add that in. 35, 8, 9, and now that's everything. So that's our stem and leaf diagram. And remember to have this on the edge, that 2/5 equals 25 people. And now we want to state the type of skewness suggested by your stem and leaf diagram. So as we can see, we have more numbers on the higher end, so that means we have a negative skew. If you have more on your positive side, then you have if you have more on your lower side, then you have a positive skew. If you have more on the higher end, you have a negative skew. And now for the last part, we want to, for this data, find the median, the mean, and the mode. So to find the median, we have 12 values. So we just want to do, so for the median, we have 12 values. So we just want to do 12 divided by 6. 12 divided by 2, which is just 6. We want to find the 6th value. So 1, 2, 3, 4, 5, 6. So then our median is just 28. To find the mode, that's just the number that occurs the most. So that's just, in here we have 2, 1, so our mode will just be 31. And now our mean. For your mean, you just want to add all your values up and divide by 12. So if we add it all up, if you do 6 plus 25 plus 38 all the way up to 28 divided by 12, you'd get you should get 26.7, and that's your answer to this question. So yeah, this is how you draw a stem and leaf diagram. Not that complicated. Just have all your like tens values on one side, and then have your line, and then all your other numbers, knowing that you'd read 2 line 5 as 25. And then skewness, if all your numbers on the upper end, it's a negative skew. If they're all on the lower end, it's a positive skew. To find the median, you just work out how many numbers are in total, divide that by 2, and then you'll get your position of your median, then just count it out to get your position, which we got 28. Find the mode is the number that appears the most, so we just have 1 here appears most in 3, so that's just 31. So your mean is you add all your values and you divide it by the number of values you have, which is 12, and then you should get 26.7. So that's how you, that's a question related to stem and leaf diagram. So that's everything. Thank you so much, everyone. Hope you found that useful, and you can now interpret tables and diagrams for single variable data, and you also understand that the area in histogram represents frequency. So make sure you do some practice questions just to make sure you fully understand how all these different tables and diagrams work, and how the different ways in which they represent types of data.